Welcome back to Rock the JVM, folks. This is Daniel, and in this tutorial, you are watching ZIO HTTP. So in this tutorial, this video is probably going to get a little long, so I'm probably going to split it into multiple parts. We are going to learn how to spin up web servers with ZIO HTTP, and we are going to go through a lot of features that HTTP supports. So the assumption here is that you know some ZIO foundations and that you want to write some HTTP servers based on the ZIO stack. Now, this relies on some essential knowledge of ZIO, which I teach in the ZIO course that I've launched just recently. So if you want to learn ZIO, check that one out. And as always, if you want to make the most out of this video, I recommend that you write code with me so that you get some hands-on experience. And whenever you need to refresh your memory, just refer back to the video or to the blog where we have a long-form blog post describing everything that we discuss in this video. All right, so without further ado, I'm going to navigate back to my development environment where I've made an object called ZIO HTTP. And I have in my build.sbt, I have some ZIO libraries that I installed for this little project. So obviously ZIO, which has just launched its 2.0 version, and ZIO HTTP, which currently has a kind of a weird name, io.d11 and ZHTTP. I guess that this name will probably change to dev.zio and ZIO-HTTP, much like the rest of the core ZIO libraries. At the moment of this recording, it's 2.0 RC11 and it supports ZIO 2.0. I'm assuming that by the time you watch this video, ZIO HTTP will probably get to a final release. But the things that we will discuss in this video are unlikely to break. So we are going to talk about the core HTTP features that ZIO HTTP supports. So rest assured, we are going to talk about things that you'll probably see in the released library. Now, because I'm starting from scratch, I'm going to say extends ZIO app default. And because I'm extending ZIO app default, I'm going to have to override the run method. For now, I'm going to simply do nothing. And here I'm going to import ZIO everything, and I'm also going to import zhtp.everything. I'm pretty sure that by the time the library is finally released on ZIO HTTP 2.0, the name here will probably be different, probably zio.http or something like that. But for now, I'm going to use the package that works at the moment of this recording. Okay. So I'm going to define, let's call this a port. I'm going to spin up my first server with ZIO HTTP. I'm going to say 9000, for instance. This is going to be the port that I'm going to open that on localhost and test a bunch of HTTP services. Cool. So I'm going to define an app that is going to be an HTTP. So I'm going to have HTTP exactly as it is. And I'm going to import that from the ZIO HTTP library. And HTTP has 4 type arguments, much like ZIO. ZIO has 3, as you probably know. So ZIO has an environment type, which denotes the requirements for that ZIO effect to be executed, an error type, which might denote the failure of that ZIO, the value type, but HTTP has an additional type argument, which is the response. So an HTTP will have the requirement, the error type, the request, and the response. So I'm going to note that as request and response. So I'm going to have zhtp.http. So I'm going to have .http.everything. I didn't remember the package off the top of my head. But these are the types that are native to ZIO HTTP, request and response. And the way that we can build an HTTP application is to define a series of endpoints, as you probably know. So I'm going to use a structure called http.collect. So I'm going to have to collect all the requests. So collect request. I'm going to add that as a type argument. And the collect with the type argument request will have a partial function that will treat all the possible endpoints. And being a partial function, I'm going to start with some cases. Now, the possible cases for requests are tuples that first denote the method, the HTTP method, and the path of that particular HTTP request. So I'm going to use method.get, for instance, associated to, so this is the tuple, the first member is method.get, and the path is going to be the root path, and the root path is this funky operator exclamation, exclamation, then an operator, which is slash, and then I'm going to have a path argument, which is owls. Owls because Mark Rudolph, the original writer of the article, named the blog post The Rest of the Owl, because there is a funny meme on the internet. So what this means is a tuple with method get and the path starting from the root with the path segment owls. Cool. Now, if that's the case, so if this thing matches, then we will issue a response. So I'm going to say response.text with some plain text, like hello owls or something like that. Cool. So notice that we can say HTTP collect and we can specify all our endpoints as partial functions. Now, throughout this video or mini series, depending on how long the video becomes, we will enter a variety of features that ZIO HTTP supports. Anyway, cool. So an HTTP server is essentially a partial function between a request and a response. I can define an HTTP application in terms of ZIO effects as well. So I'm going to call this Z-app. Again, as an HTTP with any and nothing, request, and response, which by the way is called UHTTP. So I'm going to have UHTTP app. And this takes no more type arguments because UHTTP app is so popular because we're using any, nothing, request, and response all the time. So UHTTP app, and I can say http.collect. So collect, and there are versions of collect. For example, collect ZIO, which is very popular. And collect ZIO will take as a type argument, I'm going to use request, and obviously I'm going to have the same kind of partial function. So in case I get method, let's say post, for instance, associated to the path root/owls, as before, I'm going to return a ZIO effect instead. So I'm not going to return a plain response, but a ZIO wrapping a response. And ZIO effects are very, very powerful, as you probably learned in my ZIO course. So I'm going to have, for example, a randomly generated response. I'm going to say random from ZIO. I'm going to have next int between, let's say 3 and 5. And this is a ZIO effect wrapping an int, so it's a UIO. So I'm going to have to map that. And considering n, I'm going to respond with a response with text. And I'm going to say hello times n, and then plus owls, or something like that. So every time we post a request to this ZIO application, I'm going to generate a random number between 3 and 5, and then the response will be mapped accordingly. But notice that this is a ZIO effect, and this ZIO is very, very powerful because ZIOs can pretty much do any sort of computations, creating resources and reading from databases and so on and so forth. So ZIOs are very, very powerful. Now, if you want to combine these two applications together, let's call this combined, you can combine an app defined somewhere. For example, if you want to define some endpoints for a particular section of your application, for example, for authentication, and some other endpoints for, let's say, you want to push some data to your application, you want to combine all of them in a big server, let's say app plus Z app. This plus is a double plus denoting a concatenation, which means that if a request doesn't conform to everything that's described in this app, so if this partial function doesn't match for our request, then this other app will be tried. If the first app does match the request and it fails, the second app will not be tried. There are a bunch of other combinators. For example, this thing, which is less than greater than, it's called or else. So this is or else, which means that if the first app fails for a particular request, then this other app will be tried. All right, so the same request might be matched between several different applications. I'm going to use concatenations because this endpoint is very different from this other one. Now, the blog post, as well as the official documentation, will describe all the differences between all the operators that you can put between two different ZIO HTTP applications. Right, now, how do we actually start an HTTP application? So we've defined what it means to have an HTTP server. So this is the description of an HTTP server. But in order to actually start it, we need to invoke some methods to then obtain some ZIO effects and then run that ZIO effect. So I'm going to define a val, let's call this HTTP program. And I'm going to run a for comprehension. So I'm going to have, for instance, I'm going to start a console. So I'm going to say console.println, And I'm going to say starting server at, and I'm going to inject the port. And you might want to say HTTP localhost, and then the port. Okay. And then I'm going to have this combined thing as server from HTTP service. So I'm going to say server.start on the port, and we need to pass the logic, which is the HTTP application description that we created earlier. So I'm going to have combined. And the start method returns a ZIO. So notice that this returns a ZIO with whatever requirement the HTTP app might have had. And the exception that might be thrown in this case is a throwable. So it's a Java-lang throwable. It returns nothing because the HTTP application is standalone. And then I'm going to yield, let's say, unit. And finally, in our main application, we can simply use this HTTP program to run our ZIO app. So when ZIO app default is spinning up, the ZIO effect described by this HTTP program will be evaluated, including the console and starting the actual resources that will spin up the HTTP server. So we are now free to start running this application. And we should see in the console this starting server little log, and we will have the app suspended indefinitely because server.start internally calls ZIO.never. So in this little application, this will be alive for as long as we allow it to. And in my little terminal here, I've opened a terminal window. I'm going to try to test this application with a bunch of requests. So I'm going to say HTTP post, and I'm going to use localhost 9000, and I'm going to have /owls. And notice that we get a 200 OK, so we are going to get a plain response with hello, 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 owls. So the random generator issued this 3 times, now it issued 4 times, and now 4 times, and so on and so forth. So every time we get a different response. By the way, in my terminal, I'm using an application called HTTPie. So HTTPIE, you can find it online. I'm also going to attach a link in the description. And this allows me to issue HTTP requests very, very easily. So I'm going to say simply HTTP post. So the method will naturally be post, the URL. And if you also want to pass JSON payloads, you can simply use HTTP post, name equals value, and then name2 equals value2. And HTTPie will build a JSON out of these fields, name and name2, with value and value2 respectively as strings. So this will naturally give us back a 200 OK because the filter here, the method post, doesn't really take into account the query parameters or payloads of any sort. All right, now for a simple HTTP server, this thing may do the trick, but for a complex HTTP server, it's everything that happens in between the request and the response that the entire magic happens, which is called a middleware. So a middleware is a piece of logic that transforms a request into something else, and that something else is turned into a response. So I'm going to give you an example of a wrapped HTTP application with a middleware attached to it. So I'm going to call this wrapped as combined the HTTP application that I had earlier, and I'm going to decorate this with a funky operator, which is this double add operator. And then I'm going to use a construct called middleware dot, and I'm going to have, let's say, debug. Middleware.debug is a piece of logic that intercepts all the requests, logs them to the console, and then fetches it back to the combined application, which then turns it into a response. So the way that this works is that the request goes to the middleware, then goes to the combined application to process a response. So let me use this wrapped application here. Instead of combined, I'm going to use wrapped. I'm going to restart my application. I clicked the wrong button here. So let's run this again. And in my terminal, I'm going to issue pretty much the same request. So starting server at localhost. And then I'm going to say HTTP post whatever. And notice that we have a 200 post /owls 32 milliseconds. So this is how this HTTP request was logged. Now, obviously, we can build our own middleware, and I'm going to show you how we can build our own. So outside this application, I'm going to create an object. I'm going to call this verbose that will add some more detailed logs as requests start coming in to our HTTP server. So I'm going to add a method called log. And I'm going to have a type argument R and type argument E for errors. And let's say that this returns a middleware. So this is going to be a middleware. Notice that this has a bunch of type arguments. And in this case, I'm going to have my environment type R, the error type E, and the input type for the HTTP application that's going to go through this middleware, and the output type for the HTTP application that will result after applying this middleware. So in this case, I have request and response. So an HTTP application processing requests through responses will then be processed through this middleware, and the end application will be an HTTP application with request and response. So it's as if you want to transform a function request to response into, I'm going to use this funky arrow pseudo operator, request and response. Request and response. So it's as if you want to transform some functions. So it's pretty much like function composition, but in a more detailed way with all these type arguments. So I hope this makes sense. So I'm going to have a new middleware. So middleware with all these type arguments. So I'm going to have, I'm actually going to copy all of them. So I'm going to have request responses, RE, and all that good stuff. So I'm going to have new middleware with everything. And the fundamental method is called apply. So the apply method will take a type argument R, which is a subtype of R because of covariance and contravariance, and likewise for the error type, and the wrapped HTTP application that will push everything through this middleware. And I'm going to return another HTTP application with RE request and response. So I'm going to have, as a result, type an HTTP with R1, E1, request, and response. And I'm going to have HTTP, the original application that I have here as argument, and I'm going to use two constructs. I'm going to use map and contramap. First of all, I'm going to use map because that's easier. So let's say we have a map that takes a function from response to a different type, which is another response in our case. So this is a function that will transform the response from the first HTTP request to the response that the other HTTP request will serve back. So mapping is pretty easy. I'm going to use map ZIO because instead of a plain value, you can return an effectful type, which is ZIO. So this is more powerful. So let's say I'm going to use map ZIO just for type inference purposes. I'm going to use the type arguments R1, E1, and response. This is the end result type that I'm going to return because with all these type arguments, the type inferer might have some trouble inferring all my types. So considering the response that I get from the original HTTP application, I need to report back another kind of response. So I'm going to have, let's say, a for comprehension, and I'm going to start printing something. Let's say I want to debug a lot, so I'm going to say console.println, and then I'm going to say simple token here, and let's say the response.status. So this is logging the response status. And then I'm going to go through the headers of the response, for instance, and print them each. So I'm going to have ZIO.forEach. And the response from the original HTTP application will have a field called headers. And then I'm going to iterate that. So I'm going to have toList because the headers, I think, is a chunk or something like that. So the headers is a headers application, a headers data structure, and this has a bunch of extra arguments. I don't know why so much wrapping, but I'm going to turn that to a list. And for every header, I'm going to return a ZIO returning unit. So I'm going to have console.println with, let's say, this little token, and I'm going to use header_1 because this is the name of the header. It's kind of like a tuple. And then header_2, which is the value of the header. And I'm going to yield the original response because I don't really want to process the response itself. All right. Now, it seems IntelliJ is unhappy with my code, so let me recompile this and figure out what's wrong. So we have IO exception and response. So I think I should bound this E type as a super type of IO exception in this case. So this should be a upper bound or lower bound on IO exception, but I'm going to use exception in this case, or even throwable for that matter, so that the console.println may return a ZIO effect failing with an IO exception, which is obviously a subtype of E, whatever E is. So this is the logic behind it. Okay, so map ZIO is pretty straightforward. It processes the response from the first HTTP application and returns another response, which in this case is the same, but I'm doing something in the meantime, which is why this map ZIO is quite useful. Now, likewise, I can process the requests of the original HTTP application so that they go through the middleware and then return the appropriate HTTP response. So I can process the requests first before going through this logic and then process the responses after through map ZIO. So the equivalent way of processing requests before they get into this middleware is called contramap. So I'm going to say HTTP map ZIO and so on and so forth. I'm going to indent that to make this a little bit easier to read, and the equivalent construct is called contramap ZIO, which processes the requests first. So like I did map ZIO before, I'm going to use the type arguments R1, E1, and request in this case, request, so that I have some type completion here. And given a request, I can say a for, and I'm going to, let's say, yield request, because I don't want to change it in the meantime, but I'm going to do something that is effectful, so this is why I'm returning a ZIO. So I'm going to have, let's say, console.println, and I'm going to use this other token, which is the received token in my little terminology, and I'm going to inject some fields, let's say request.method, and then request.path, and then maybe request dot, I don't know, version or something like that. And then I'm going to go through the headers of the request in much the same style as I did for responses. So I'm going to have ZIO.forEach, and for each request headers to list in much the same way. I can take a header and I'm going to print line much the same thing. So I'm going to have to print that with the different token, header _1 and header _2, and I'm going to yield the same request. So notice that I'm using contramap and then map. Now, why am I doing that? The way that this works, the way that this middleware works, is that the request goes through the contramap and then goes to the HTTP application, and then we get the response, and then we get the map, and then we get the final response. And by this little absolutely amazing diagram, so this whole thing from here all the way to here is the middleware. So this is the middleware, which wraps the entire HTTP application. Now, in technical terms, between the request and the final response, we get the new HTTP application, and the processing of requests plus the processing of the responses is where the middleware comes in. All right, now let's go test it. So I'm here going to create a new, let's call this logging HTTP as combined with the same operator, and I'm going to use our own middleware, which is verbose.log. And this is a new middleware object which can wrap this login HTTP. So let's try running this again with our logging HTTP plugged into server.start. Let's compile and run this. All right, and it seems to be working. Now, let me go back to my terminal, and I'm going to post this a bunch of times, and notice that the new logic starts kicking in. So we have post, owls, localhost, user agent, and so on and so forth. All the headers are displayed here, as well as the response, which is OK, and then all the headers, content type, and text plain. OK, cool. So this is how you can add your own middleware on top of an existing ZIO HTTP application. All right, now, in this part, I want to show you some more advanced features of ZIO HTTP, and in particular, I'm going to show you CORS, which is quite popular if you want to create your own website, and this is called cross-origin resource sharing. And also, cross-site request forgery, so CSRF. These two are very important if you have a data/content intensive website. And if it just so happens that you want to build that on top of ZIO HTTP, then you'll have to deal with these. All right, let's take them in turn. So CORS, cross-origin resource sharing. What is that? It's a mechanism to allow websites to allow traffic from other origins. So for example, if you have rockthejvm.com, without any CORS config, then somebody at youtube.com may issue automatic requests to rockthejvm.com and bring whatever videos I have on Rock the JVM and automatically add them to YouTube or something like that. So somebody might crawl my website, and whenever you enter their website, they actually request my website for whatever content I might have there, which is not really that great because you end up paying for all the traffic. You get to pay for all the data traffic and so on and so forth. So CORS is quite useful to have for pretty much any website. So CORS can help you block requests from other websites. Now, in addition to that, CORS can also help you with verifying that you can interact with the server at all. So, for example, if Rock the JVM was a platform where each user might be able to upload their own videos or pictures or something like that, you would be very wise to add the capability of Rock the JVM to support some pre-flight requests so that you know for a fact that you can add some sort of resources to Rock the JVM from some other resource. And if rockthejvm.com denies you that, then it's no point uploading videos or pictures or data-heavy resources to Rock the JVM because the website doesn't allow that. So let me show you how that works. So I'm going to define a val, let's call this CORS config, as CORS config with a capital C everywhere. So CORS config, this is a plain data structure, and you can have a bunch of flags here defined in the CORS config. I'm going to use any origin equals false. We have any method as false, and very importantly, we will allow certain origins. So allowed origins, I'm going to pass a function that say s equals localhost. So any other website other than localhost will be denied from Rock the JVM. And allowed methods, let me add a comma here because otherwise the Scala compiler will be unhappy with me. Allowed methods, this is going to be an option, and I'm going to have a sum with a set. So a set with method.get and method.post, for instance. Any other method will be denied. So from a browser, if you want to access our little web server here at localhost, you will be able to do that. But if you want to call localhost from another website, you won't be able to do that. Okay. Now, this CORS config thing can be wrapped in a middleware as we described in the previous part. So I'm going to have, let's say, I'm going to put that on top of the HTTP program. And I'm going to have my CORS enabled HTTP as the combined HTTP application, which I defined earlier, combined, and I'm going to use the operator middleware.CORS with this CORS config. So CORS config. Now you can obviously add multiple middlewares. So for example, I can add the verbose log that I added in the previous part. And we can also add the middleware.CORS. And I'm going to use this CORS enable HTTP here in my HTTP program. And I'm going to restart the application. Let's see what happens. All right, so we have localhost 9000. Cool. Now, let me get back to my terminal, and I'm going to use an HTTP get at localhost 9000 /owls. Okay. Now, in this case, we get the request, which is accepting coding and so on and so forth, that we saw in the previous part. But I'm going to also add an HTTP header in the request. So I'm going to have HTTP get on localhost 9000 /owls. And I'm going to have, in between single quotes, I'm going to have my header pairs. I'm going to say origin, colon, let's say, rockthejvm.com tries to access a resource from localhost. And I think this is me being stupid. So I'm going to have my origin rockthejvm.com after the URL itself. All right. So we have hello owls. Now, if you take a look at the headers for both the requests and the responses, nothing has changed from the original HTTP request by just getting a localhost with no origin. So if you set an origin that's unknown or set no origin at all, you'll pretty much get the same kind of behavior. What this means is that if you navigate to rockthejvm.com and the JavaScript on rockthejvm.com tries to fetch this resource from localhost, the browser will block this request. That's what it means. Now, let's try a different kind of origin, which is included in this little set. So I'm going to issue the same kind of request, so get localhost 9000 hours, and then I'm going to say origin is localhost. Now, notice that in this case, we get some extra headers. So access control, allow credentials, and so on and so forth. These are CORS headers, which means that the browser would allow this request. Now, in theory, we should be able to see these headers in the logger, but I don't see them anywhere because the verbose log is in between. So we can add that at the end to wrap all the headers returned by middleware CORS. Let me restart the application and let's try this again. Maybe we'll see the CORS headers here in the console as well. Let's try this one again. All right, so at this point, notice that we get the CORS headers. So notice that the order of middleware also matters in this case. Cool. Now, the more complicated thing is CSRF. CSRF is cross-site request forgery. What does that mean? Let's say that you're logged in, to some sort of website. Maybe it's your online banking or online store. Let's have a slightly more benign use case. So logged into an online store. Now, you also have a browser plugin, and the browser plugin will issue or will change the HTML on your page to display a button. When you click that button, this will trigger a form submission, because you're logged into the online store, so the browser plugin might log your username and password. And when you click that button, let's say, I don't know, check out this new offer on the online store, the browser plugin will trigger a form submission to the original online store, for example, to change your email address. And this form submission is hidden because you can issue an HTTP request without actually displaying the form, of course. So without you knowing, this browser plugin changed the account, which has, for example, some credit card data already stored. And this is problematic. So this vulnerability is due to the fact that you're logged into an online store. Somebody, or the JavaScript of the page itself, the online store itself is malicious, so it stores your username and password. And the JavaScript, when you do something or at a certain point, it will trigger a form submission to change the username and password associated to your account, except, of course, your credit card details, and you end up locked out of your account. This is the situation for which CSRF adds an additional protection. So really good websites will have the CSRF protection in place with a mechanism called a CSRF token plus a cookie. This is called the double cookie or the double submit cookie approach. So double submit cookie. That means that whenever you want to do something with your account, you need to also send this little token and the cookie that the website gives you back when you logged in the first place. And these two must match so that you might end up calling some endpoint associated to your account so that other malicious code, for example, a JavaScript that is from a browser plugin or an external website, might not forge requests such as a form submission without these two already set, which they have no way of checking unless you are a real user logged into a real website. Now, there are whole books written on this subject, and I explained that in 30 seconds, so I hope that makes sense. And I'm going to show you how you can enable CSRF for a ZIO HTTP application. The way that you can enable CSRF is to add another middleware, so in the same style as we did in the previous parts. So I'm going to show you how you can have a CSRF generation and validation in some HTTP endpoints. So for example, I'm going to decorate the first application with a middleware dot, and you have a CSRF generate. And I'm going to define this other Z application with add middleware dot CSRF validate. So this will generate the token that you need to save as a cookie, and the middleware CSRF validate will then check whether those two are set and equal. So let's run this to see how it works. And I'm simply running this application because the combined application is app plus zapp, so these two combined. And then the combined is wrapped in middleware CORS and then under verbose log. So we will see all the HTTP headers for both requests and responses in our console. Okay, so let's interact and inspect these endpoints via our little HTTP application. So I'm going to say HTTP get at localhost 9000/owls. And notice that we have a cookie header, which is set cookie, which a browser would happily store locally. So X CSRF token is this little thing. All right. Now, if you want to ask the Z application for the other endpoint, method.post/owls, then you need to set your cookie to exactly this value and also the HTTP header XCSRF token to exactly this value so that the endpoint will reply back with a 200 OK. So let me try to access our post endpoint. So I'm going to have HTTP post, and I'm going to have localhost 9000/owls. And notice that we have a forbidden. It's a 403 because we have CSRF activated. Now, in order for this endpoint, the post endpoint at 9000/owls to work, we need the cookie and the token itself. So I'm going to have HTTP post 9000/owls, and I need the header, which is X-CSRF token. I'm actually going to copy that. So X-CSRF token is this thing. Okay, so the header itself. And I'm also going to have the cookie itself. So I'm going to say cookie colon X-CSRF token equals this little thing. So this argument is available under HTTP. You can also do that with curl. I'm also going to show that to you. And apparently I have forbidden. I think I've mistyped the syntax. I need a colon here. So XCSRF token is the header name, and this is the header value. Hopefully this one works. All right, so we have a 200 OK, and the endpoint works as before. So notice that we have XCSRF token and also the cookie that's set by the HTTP request. So the CSRF token with the double submit cookie mechanism will ensure that no third party will be able to access your endpoint unless it has somehow access to both the cookie and the token that the website initially generated. All right, cool. So that was CORS and CSRF. Now, the next thing I want to show you is authentication. And I'm going to cover just basic authentication with usernames and password. ZIO HTTP will support various forms of authentication, but I'm going to show you how authentication works with some plain username and password. So let me go at the top, and I'm going to define, let's call this auth app. This is going to be same kind of HTTP application. And I'm going to use http.collect, not collect ZIO, so simply collect because I'm going to return some plain values. And I'm going to have collect requests. And I'm going to add a partial function. So in case I get a method.get, and I'm going to associate that to the path root and then slash, and then I'm going to say secret and then /owls. I'm going to return a response. So response.text. And I'm going to say the password is Rock the JVM or something like that. Okay. Now, this auth application, I'm going to decorate that with a middleware. So I'm going to have at middleware.basic auth, and there are a variety of basic auths here. I'm simply going to use a basic auth with a particular username and a particular password. The most complex or the most general basic authentication is basic auth ZIO, which receives some credentials, and it runs an effect returning a Boolean whether those credentials are appropriate. So this is the place for using a database, for example, where you can hash passwords and so on and so forth. So this is the most general basic auth ZIO that you can use. I'm only going to use the very easy one, basic auth with username and password, and I'm going to say Daniel, and the password is obviously Rock the JVM or something like that, or Rock the JVM 1 exclamation mark with a capital R, so that we can satisfy the usual request for passwords. All right, now I'm going to use this auth application independently here under the HTTP program. So I'm going to remove the CORS and I'm going to use this auth app just to show you how this thing works. So I'm going to run this application, and we now only have a single endpoint at method get /secret/hours, which is what I'm going to exploit here. So I'm going to say HTTP get at localhost/secret/hours, and I'm going to get a 401 unauthorized because I haven't supplied any username and password. So I'm going to say HTTP, I'm going to say -a, and I'm going to have my Daniel Rock the JVM 1 exclamation mark combination. And then I'm going to say get localhost secret hours. If I remove get, I'm still going to issue a get request. I think for curl, you have --user with the same kind of format. And notice that in this case, we have a 200 OK because the authentication was successful. Now, this is the place where you can create a middleware with the basic auth, and the validation, the credential validation is its own logic. So you can have credentials, and then you can have some ZIO that returns true. So for example, ZIO succeed true. This will, and right now the IDE is unhappy with me because it's called basic auth ZIO. So for any credentials, you will return true, but obviously you will change logic here to interact with your own database, with your own password validation, and so on and so forth. All right. So I'm going to simply revert back to my basic auth with Daniel and Rock the JVM 1 because I've already made the point. Now, one problem that might arise with defining the HTTP application piecemeal like this is that you now have to take very good care how you want to order these endpoints. For example, let me assume that I'm going to put auth app at the top. So auth app comes first. If that is the case, then every endpoint needs to be authenticated because if the auth app doesn't respond with the basic auth, so if the authentication fails for auth app, then these two are not taken into account anymore. So for example, let me rerun this application with this combination. So auth app comes first, and then app, and then Z app. So let's run this. And I'm going to obviously try to log in. So the login works correctly with Daniel and Rock the JVM.1. And if I do HTTP get at localhost 9000/hours, which was my basic endpoint, I get an unauthorized because the auth app comes first. The first is the validation, and then the other endpoints will only succeed if the authentication was successful. So that's not right. If I put auth app at the end, so if I put auth app at the very end, then the CSRF validation will not take place because auth app doesn't take in any CSRF tokens into account. So that will also fail. So the way that we need to put that is in the middle between the CSRF generation and the CSRF validation. So be really careful about the order of routes, especially if you use authentication and other forms of middleware, for example, CSRF. All right. Cool. Now, one last thing that I wanted to show you for this little tutorial on ZIO HTTP is Websockets. So Websockets, the authentication came before, so I'm going to have my authentication here, and then the CSRF, I'm going to add it at the top. So this is going to be CSRF validation and CSRF generation. And now I'm going to talk to you about WebSockets. Cool. So WebSockets are also created using the same HTTP construct, but instead of collecting requests, we typically collect something called WebSocket channel events. So communication will happen over this channel, and instead of returning responses, which are HTTP responses, we will return unit. Now, At a lower level, we are going to use a channel, which will allow some arbitrary sending of messages of a particular type. So if I type in channel event, I think this is built in from ZIO HTTP. This channel event is a case class which takes an input of type A and returns a value of type B. Now, all WebSockets or WebSocket messages are instances of these channel events. I'm going to show them to you shortly. So let me define a little program. I'm going to call this sarcastic, which is a function from string to string that just issues responses based on some sort of input. And let's say I'm going to have text, and I'm going to say text to list, and I'm going to say zip with index. So I'm going to split that by characters, and then I'm going to map that. And in case we get a character and an index, then if the index mod 2 is equal to 0, I'm going to turn that into an upper character. So c.to upper. Otherwise, c.to lower. So I'm going to type in mixed cases, and then I'm going to mix string back. So make string. All right, so depending on the input string, I'm going to turn that into upper and lower characters depending on the index of that particular character built out of these characters piece by piece. Cool. Let me define my WebSocket logic. So WebSocket logic. This is an HTTP, and this will have any and throwable as the first types. Now, the input type is WebSocket channel event. So WebSocket channel event that I need to import. So I'm going to import that from ZIO HTTP, and the final output is going to be unit. Now, I'm going to use the same HTTP construct that I did for the server. So I'm going to say HTTP collect ZIO for these events, so WebSocket channel event. And then I can add a partial function. So in case we get a channel event with a channel and the event that I'm going to use as channel read. Now, the channel read is a particular kind of event, and the message is of type WebSocket frame dot text with a particular message. So WebSocket frame is actually the companion object. I think I haven't imported the right thing, not from Netty. I need to import that from ZIO HTTP. All right. So WebSocket frame.text with a message. So notice that the structure here is a little bit more complicated. Now, I need to use this channel to push a new output back. So I'm going to say channel.write and flush. And then I'm going to process a new text message. So I'm going to say WebSocket frame.text. I'm going to use text with a lower cap t because the text thing is a factory method. And I'm going to pass a new string based on this message, and I'm going to invoke this sarcastic function over that. So sarcastic invoked on message. So essentially what this says is that as soon as I get a message as a WebSocket, I'm going to push a new message back to the WebSocket. Okay. Now, in case we get a channel event with channel and a different kind of event, for example, user event triggered. User event triggered is a different kind of event that can be created as a WebSocket. I'm going to run a pattern match on that. So event match. And user event is usually a handshake from the protocol of the WebSocket. So I'm going to have to match a case for handshake complete. And I'm going to invoke and import that. So I'm going to say user event, and I'm going to import everything here. Cool. So in case I get a handshake complete, then the WebSocket is established. So I'm going to say ZIO.loginfo. Then I'm going to say WebSocket started. Now, ZIO loginfo can be replaced easily with console println. So console.println, WebSocket started. And then in case we get handshake timeout, then I'm going to say console.println with connection failed. So you need to also trigger this user trigger event. So this is these are ZIO's returning unit, which is okay. Now I'm going to eliminate the channel because I don't need that. And in case I get a channel event with a different kind of event, which is channel, I think it's called unregistered, this means that the user has stopped the channel. So I'm going to have a console println. So console.println. Then I'm going to say connection closed. Okay, so this is the WebSocket logic that will trigger all the content and the so-called WebSocket related events. So I'm going to eliminate the channel here. And I'm going to define a WebSocket application. Let's call this WebSocket app as http.collect ZIO. And collect ZIO, I'm going to instantiate this WebSocket logic as soon as somebody tries to access a particular path. So collect ZIO with request. So somebody will try to issue a GET request on a particular path. So in case we get a method.get associated to the root, let's say /@ws or socket or talk or chat or something like that, I'm going to start this WebSocket logic. So I'm going to say WebSocket logic, and I'm going to say to socket app, and then to response. And this is a ZIO. All right. So this is a ZIO issuing responses. All right. Cool. Now, this is a new HTTP application, so I'm going to use that as server.start so that we can test that. And I'm going to show you how you can use that. So let me rerun the application. And for this example, I'm going to use another application, which is called Websocket. I'm going to attach a link to Websocket GitHub in the description. And I'm going to have Websocket, and I'm going to prefix that to ws// so this is the protocol, localhost 9000/chat. And notice that at this point, the WebSocket has started, and notice the application's console says WebSocket started. So I'm going to say hello. Notice that the WebSocket replies with hello with mixed cases. The console doesn't print anything. How is sarcasm going? And notice that WebSocket is funny. Okay. Cool. So I think you got the idea. All right, folks, so this was a pretty comprehensive introduction to ZIO HTTP. I hope you found this valuable. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on LinkedIn and Twitter. I post fresh updates on upcoming material. And check out the Rock the JVM website, as I have literally hundreds of hours and tens of thousands of lines of code on camera on everything in the Scala ecosystem. So until next time, folks, I'm Daniel, signing off.